All right, go on ahead.
All right. So I am Stephanie. I am a fifth year PhD student in psychology and a co founder with Morgan of Our Ladies, the Fayetteville chapter. And so Our Ladies is a worldwide organization, and we are like the Fayetteville section of it. But they have their own like Twitter, and there's like all different communities within Our Ladies to kind of get connected with people and learn new things. But our kind of specific Fayetteville chapter has some primary goals. So, along with the Our Ladies Global, we want to promote representation of diversity in R and coding. And we want to connect people in the Northwest Arkansas area who do R. So, we're always trying to find new members, even outside of academia, and try to connect people and um, offer new skills like this, and create a space for collaboration and support people kind of across different levels of R. And really, ultimately, it would be awesome if we could connect those people through the organization to potential like networking things and career opportunities based on their like experience and connections with R. So this was a really cool opportunity to get to kind of collaborate, and we're totally open to future collaborations, and hopefully can, as we kind of expand, get more access to like promoting things like this. And it's so hard to promote things like virtually right now because there's only like a few outlets of that, but I'm excited to learn about some web scraping. And Morgan put in the chat a link to a um, Google form if you want to join Our Ladies, or you can email me or Morgan also.
Great, great,
Sounds
great.
good. Thank you very much.
Stephanie, thank you for doing that. My name is Joel Thornton. I'm the head of research and instruction services for the university libraries. I've been at the U of A for about 5 years, and we are delighted to have the opportunity to collaborate with you. We look forward to future collaborations, and like you, as part of the university land grant missions, we are looking to extend our reach to the NWA community and as well as the state. So again, pleasure meeting you and welcome everyone. And we look forward to future collaboration. So
Yeah, great meeting you.
All right, so allow me to share my screen and I think we'll get started. Clean that up. All right, so are you all able to see this first slide?
yes.
Yep.
Very nice. So, hello everybody. Welcome. My name is Austin Wilkins. I'm a graduate student at the University of Arkansas, and I work with Joel at the University of Arkansas Libraries, developing new data services and working on outreach programs such as this. So today we're going to be talking about web scraping, and a few things that I really want you to keep in your mind as we go forward is that web scraping can be uh, it's a part of the data gathering process, and it can be pretty quick and pretty easy if you know what you're doing, and it'll open the door to just vast amounts of data that you can bring into your disposal. So first thing I want to do is go over a quick outline of what we're going to talk about today. We're going to start with just an overview of web scraping, 5 minutes, a couple slides, a few terms, pretty simple. Then we're going to talk about some use cases, practical things that have been done on our campus that could not have been done without web scraping, things that I've done either in support of researchers or professionally, and things that you can do in your own work to take advantage of this tool. And then we're going to go in through a walkthrough example. And here I'm actually going to open the RStudio and perform a web scrape, show y'all all the steps, what the process is as you go through it. And now this is a little disingenuous because we actually already did it this morning and, it worked well. So we have a write-up, and I believe Joel's put that into the chat. And if you want, you can download it from there. It's an HTML write-up created in R Markdown that has all the code that you can copy out and explanations for everything that we're doing. Or if you'd like, you can open up our studio and then follow along with me. And then we're going to wrap up with a few key points at the end. So to start, from the very basic, what is web scraping and what is better than a Wikipedia quote? It's a computer software technique of extracting information from websites. And that's all it is. It's useful for gathering large amounts of web data. It's useful as a method of automating repetitive data gathering tasks, such as something that you would run every day or every week, or every 5 minutes. And it focuses on interacting with the HTML of a web page to gather data. This means going into kind of the text code that is behind what we see, and we can look through that for keywords, tags, that sort of thing. Now, for why we're using R for web scraping, R is, well, for one, it's a free and open source language, which has a long history of being great. It's a great data analysis tool, and it has great data analysis tools in it, such as the tidyverse, which we'll be using. So once we're able to bring our data in, we can just do all of our analysis and data cleaning right here, and very easy. We have the wonderful RStudio IDE, which is my favorite IDE, and I think a lot of people would agree with that. And we're using R as opposed to any sort of point and click or GUI option, because as a programming language, it's typed out and written, and that's going to allow us to share code with other people, read our own code in the future, copy it and alter it in little subtle ways that will give us, which will allow us to make these flexible little programs that we can use in a lot of different scenarios. So a couple of use cases. There we go. A couple of use cases, just to cover that. Gathering online data that's updated daily, something like news headlines, numbers being put out by different organizations. We did some outreach work with the Arkansas COVID group to gather the state COVID numbers from 7 or 8 different sources and aggregate them all using R and web scraping, clean them and put them in a single database, and we update or upload that into the Arkansas COVID database every day, and that's completely written in R. Gathering large amounts of data from a single site. Here we have the researchers love doing this, and the public policy or the political science international relations group has, we've worked with them in the past to gather, I think it was like 30,000 lobbying records from a specific period of time over some specific congressmen. And that's something that would have been impossible to do.
Hey, Austin.
Yeah.
Hey there, just a comment. Ian says I can definitely see some incredible uses for this once you get the hang of it. And then Morgan says, I agree. So, all right. So
yeah, sorry, I had my chat covered up by another window.
No, I'll watch it. Don't worry about it. So,
oh yeah, I just, make sure I'm there. I'm glad you can see some incredible usage, because there certainly is. And then gathering similar data from many different websites. And that's something that we're going to be doing today. And that's going to be part of our practical example that we go through. And everyone's talking about Popeyes and Cane's chicken for some reason today. And finally, a couple actual projects. I just put this in here so it would be on record. It was asked about from our morning session. Gathering data, daily updates for ArkansasCovid.com. scraping opensecrets.com for members of Congress lobbying data, scraping comments from, these are projects that are going on campus right now, or projects that I have personally helped with. And we had a question from our earlier session about ways you could do this, not just for research, but for money. And there is certainly opportunity for that. The Arkansas Democrat Gazette puts out like open contracts on data every now and again. Various local small businesses are always looking for very specific data pulls, or maybe a one-time thing or a program that they can use. And of course, there are employment opportunities. Josh, what you're saying, what's money? You're right. As researchers, we don't care about money. And this second point I want to hear, the scraping opensecrets.com for members of Congress lobbying data. Before the chat, I was asked about how I got started about this, and I just wanted to point out that this is something that we've done with the International Relations Group a number of times. And the first time was when I was actually a grad student in that program. And I was given the task to copy and paste certain data from lobbying reports for 20 hours a week for the whole semester. And a guy had done it the semester before me, 20 hours a week. And two different professors were going to spend about 20 hours a week doing it all summer, which is ridiculous. So I asked my professors if, instead of doing that work, if I could try to teach myself how to write a web scraper. You know, first time I did it, it took a couple of weeks for me to figure out what was going on. It was not very well written. It took a long time to run, but it ran. And it ended up, you know, in doing multiple semesters worth of work in just a few weeks of learning. And something more, you know, hopefully today we can accelerate that to just a few days of learning, maybe. So before we start our example, I want to talk about something that's kind of like the golden rule for web scraping. We use web scraping when it's faster to build a machine than to gather the data by hand. And, you know, sometimes that's a line that you have to walk. Gathering 20 or 30 email addresses or comments from a single comment chain, you know, maybe you can do that by hand. But then if you're trying to grab the comment chain for every news article on a site every day for the whole year, that's very prohibitive to do by hand. And that's when web scraping kind of opens these doors for us. So it's good for large and repetitive tasks. So I think we should jump straight into our example. Oh, and Morgan, you bring up data entry mistakes. That's I was about to say you wouldn't believe, but I'm sure you probably understand how manual data entry is just rife with errors once you're talking about, you know, thousands or hundreds of thousands of entries. Good thing about programs is they'll do it exactly how you tell them to. And that's also the difficulty of programs, is they'll only do it exactly how you tell them to.
But I would much rather give an undergrad one of these scripts to run than have them type it out themselves, for sure.
Oh yeah, oh yeah. So we're going to be a simple scrape that we're going to do today, which is something that was, it's very similar to something that was asked of me from the public policy department to do for government employees. But today we're going to be gathering the contact information for the Walton faculty. Our goal is to gather the names and contact information of strictly the professors in the different Walton College departments. And as we're going through this, one thing that I kind of want you to think about and remember is that we'll be starting, well, the process is going to be starting at the smallest level, trying to find a single entry. And then we're going to expand that code so we can find every entry in that page, and then every entry in that department, and then every entry in every department, just by expanding on that first little bit of code that we've written. So let's jump straight into our studio. I'm going to be working in R Markdown today so that I can type comments and whatnot while we go on. And I like being able to separate my code into chunks. If anyone isn't using R Markdown or doesn't know what it is, it's kind of nice. And while I'll do my best, if I end up typing and I take about 5 seconds to talk, well, that's just what it is. So let's start by bringing in our libraries. Oh, just library. There we go. First, we're going to be using the tidyverse. This is just a suite of R packages that has a variety of analytics and data science tools. It's written by Hadley Wickham along with a couple other maintainers, and it very much expands on the R data analytics just vocabulary. And then specifically for web scraping, we're going to be using RVest. RVest is within the tidyverse. It's produced by Hadley Wickham directly, I believe. And it's what contains the various web scraping functions that we're going to be using. So I'm going to pull a page for a list, and we're going to look for the Walton faculty list. So I typed in Walton College directory and found myself here. This is the page that we're going to be trying to scrape information from for the beginning. We see we have faculty in the accounting department. That's what we're looking for in the Walton College. You see that they seem to be arranged in some way. We have their names, their titles, phone numbers, and email. It's great. And this is kind of, we're starting that exploration process, looking for that data that we want to get. And then we see down here, you know, PhD students are on the same page, kind of arranged the same way. And then we have staff. All right, looks good. So the first thing to do, I'll just shrink that over there, put that over there. Let's bring this page into our RStudio and just call it page. There we go. There it is. Call it page. So the first function we're going to be using is read HTML, which, remember, you can always press F1 in RStudio to bring up explanations of how the functions work. Read HTML, we're going to take that URL, which, you know, the title of the site, plug it in, and there we go. What that does is R will shoot out a request to that server, have it send back the HTML, and then when it comes back, it'll be turned into an XML object. So if we look now at page, it has given us an, hopefully that's not too small for you to read, and but here, page is now a object of XML document type. We have a little metadata, and then it has two nodes, head and body. So let's run both of these, and we can see that this is a list of two node.xml document XML node. Sweet. Now an XML document is it's a shorthand for extensible markup language. Extensible markup language. There we go. It's a way of organizing data where it's able to be, you can take very complex data and then split it into a straight line, and then translate and then share it to different programs or different computers. HTML is technically a markup language, which actually let me had this later in the thing, but let's talk about this right now. HTML, hypertext markup language, is a language for describing web pages. It's the text that's going on behind a web page, and we're going to be looking into it here in a minute. The information within it is organized by tags. There's an open tag and a closed tag, I think always. These tags are named different things, and many of them have searchable attributes, things like class or ID, and they may contain raw text. We're going to explore that here in a minute and actually go into some of the text. HTML, hypertext markup language, is technically kind of now it's considered like a subgroup of XML. XML is just a method of storing data that involves separating information into these different tags. But here, let me show you. We're looking at this directory, and now that we've pulled this into our page or into our studio, we need to find where the data that we're looking for is. So here, let's talk about Chris, because Chris is the first person on the page. So all modern browsers have this capability of viewing the page source. I'm currently on Firefox. Chrome, you can do this very easily through developer mode, and I believe on Safari and Edge and everything you can. But here you have the raw HTML of the page. And this is where, since we're looking at a static web page, this is where all of the information that is displayed on the page is held. And, as you can see, it is pretty long and pretty big. So, and pretty hard to read if you don't know what you're looking for. But luckily, we know we're looking for this guy's name. So we Control F, search for it. And let me zoom in a little bit so y'all can see. Here, look at that. His name is right there. And here's something that says class name and his name. So it looks like this line has something to do with him. We can scroll at the beginning and just see, profiles, style sheet. What do we have here? Directory list. Here's his name as an ID. So it seems like this line is holding the information we're looking at or looking for. Oh yeah, that one's you got his picture right there. Doesn't want to let me get back into it. We have his picture, and here we have his name. That's that information that we were looking for, right? So we can see that the name is captured within a div tag. It looks, a div stands for a division tag. It usually has class and ID associated with it. And to about here. So that is the information that we're looking for. Let's take that and bring that back into our studio. Let's talk about the next function in this package that we're going to find useful. We can take page, use the pipe operator, and the function HTML nodes. And what this does, so while page has all of the HTML, we can use HTML nodes to choose a subset of HTML nodes. In this case, we know that it was a div tag. Here, let me copy it right there. So this is the name tag that we were looking for. It seems to have class name, ID, name, and then his username. And then it looks like this is the text of that tag. So we see it's a div tag. So let's look at page, our HTML object, and then all the nodes that start with div. And as you can see, that is far too many to be useful in this scenario. So we need to subset a little bit more. And here we can search in another way. And I want to talk, I guess, a little bit about CSS, which you don't need to understand CSS. That's cascading style sheets, but you do need to know how to search it. And the two, really the only two things that I think are necessary to know for it is that if searching a class, you use a period, and it's an ID, you use a hash. And so here we're looking at this div tag within the HTML. This class and this ID can be referenced using either the period or the hash. So, and that will actually come up a little bit more in about 10 minutes. But so let's look up class name. So page, HTML nodes, and we're looking up nodes that have the name class. And we do that, and that's looking pretty good. Here's his name, but then we also TJ Atwood, Vinny Spoon. So let's look. That definitely looks like that's just every person. Nice. So, but we're still looking at things that are of the object XML node in the R notation, and we want to pull out that text at the end. So we can use the third function we're using today, the HTML text function, and that pulls out all the text that we're looking at. You see it starts with Chris, and it ends with Alice and Carrie. So let's see where they are on the page. So it's not the end of the professors, and it's the end of the staff. So it looks like we've just pulled the name of everyone in the accounting department. Nice. But we said we were just looking for the professors, and this is everything. And you know, that might not be a problem. But if you want to specifically choose the faculty in the accounting, or the professors, the faculty, then there is a way that you can separate these two. And to do this, I want to show you one additional functionality that all of your browsers have.
Joshua has his hand up.
The what?
I said Joshua has his hand up. Did you have Joshua?
Yeah. Can you hear me?
Yeah.
Yes.
Yeah. Oh yeah.
Okay. I'm curious with the R Markdown, when you get your output in your workspace, I believe, do you get more information out of that? Do you get the full amount of information? Because in my console running with not R Markdown, I get a truncated output.
I tend to the output is slightly different for each one. I think R Markdown is a little more clean for when you're doing data analysis. Like if you have multiple charts, they can just kind of appear in a row. If you're looking at, in fact, we can look at a tibble here. Oh, not page. And they'll be, there we go, names. They'll be displayed here in kind of a little bit of a pretty way. It's just a different way of showing it. It's not necessarily better or worse, but I've grown pretty used to it.
Cool, thank you. Yeah, that does look a lot better.
But I will say, and one thing I'm glad you brought that up, sometimes it doesn't have the most expressive error messages. So, you know, when things are going wrong, you can actually look directly into the console, and that's pretty helpful. So, we were trying to find just the faculty and not the students. I want to show you about this inspect element, which, by the way, if you raise your hand again, I now have that page open. Firefox it calls inspect element. In Chrome, it's called developer view. And this is an incredibly useful tool if you're trying to do web scraping that allows you to look at your HTML, and as you glide over it, it'll highlight and point out what the what element of the HTML you're looking at. It even has the name above it, which is nice. Or you can even, if you're looking down here, scroll around and it'll show you what you're looking at. So we're looking for this page here, directory box. Oh, actually, if we look at his name, yeah, there's that node that we just pulled earlier. Div with the ID of name, Dali, and then the class of name. So this is a div directory box that we're looking at. You could, and while you could find all this by just going through the raw HTML, this is generally what I end up using just because it's so quick and easy. And one small problem is that these are both called directory box. And this information has the same name. So we're gonna have to use a different method of selecting that top box. Luckily, there are other methods. In Firefox and in Chrome, the easiest thing you can do is just to right click it and go to copy, and it allows you to copy out either the CSS selector, the CSS path, or the XPath. And these are all pretty complicated things that you probably won't be able to read directly, but the XPath is not too difficult to read. So we just found the box that we're looking at using an element inspector, and we can copy out its XPath. Now, let me show you what an XPath looks like. That is what we just copied out. And that, you don't really need to be able to read this, but it's, it's the HTML and then the body tag and then the fourth div tag and the first div tag under that and the second under that. It's putting the elements in the page and organizing them as you'd organize a file within a file structure. But we can take that XPath and before we do that subset that we just did, we can do a different subset. And look up that XPath that we just found. Now, if you notice, I actually wrote out XPath instead of putting it in. It's because if you inspect the function, once again with F1, you can see that when you're using HTML nodes, the first thing it takes is the XML object you're looking at. Then the CSS, that's if you're looking at the class or putting in div or something. And then the XPath. So we actually have to type it in, make sure we're looking at that, and let's test this. And this time we're ending with Julie Wilson. So that should be the bottom, Julie Wilson here. So the bottom of the faculty. And in kind of this loop, what we're doing right now is kind of the first step of web scraping. Is finding where your data is, testing it, going back and forth, and just prodding until you're getting exactly what you want out. So this has now given us all of the names. There you go, 34. So all the names of the faculty we now have in a nice tibble, ready to go. And
can you explain what a tibble is? I know it has to do with the tidyverse, but I always forget.
Yeah, and I actually I'm glad you asked that because it was like just last week that I got frustrated with not knowing that and looked it up. A tibble is a data frame, but it has some slightly different metadata that'll show in the console or on the page. But the primary value that I get from it is it's a what you would call lazily interpreted, which means whatever you give it, it is not going to change that going. I believe it's also called static. But it's not going to change data types. It's going to look pretty, but really, you could put it in a data frame. It's kind of the same.
Gotcha. Okay. I like that feature. That's really handy to know that it doesn't change anything.
Yeah, and that, data type problems will not be a problem until they're the biggest problem and they take forever to solve, and then you have like 2 or 3 more months until once again that happens. So anything that helps with that. But so now we found the his name of Chris. Let's look up his phone number. And we can do this now that we've actually looked through the HTML once. Let's just use this selector. Click his phone number, which has a div of just A, which isn't super good, but or a tag of A. But here we go. Looks like if we look up a div tag of the class phone, it should have the text of his phone number within it. So let's just copy that code that we just did. Phones, like capitalize for no good reason. And this is my favorite part about web scraping is once you do it once, you can kind of just copy and paste everything, see if it works. So let's test that out. We should be getting we're looking at the same exact overall node, subsetting the directory box from earlier, subsetting all of the boxes within that have the phone class, and pulling the text from them. And there we go. And it looks like a lot of these numbers are actually the same. So I'm guessing that the professors aren't usually putting their real number, or maybe it's some sort of shared office phone. But we can put that into a tibble. There we go. And we now have a data frame of all their phones. Nice. And just to do that one more time, let's pull that email, CSS selector on the email. And this is another div tag with a class of email. And if you notice, this is kind of going pretty quick at this point. And that's usually in a website, once you find where some of the metadata is and how it's structured, it's going to be pretty easy to find everything else you're looking for from that. So let's copy this one more time. Emails. Run it.
So this is a tiny question.
Yeah.
So with the phone numbers, so that's actually still text, not like a number. Like when you do the HTML text, it's still going to grab the numbers, even though they're like, you know what I mean? Like they're
yeah.
number format versus like a character.
I believe they're I believe it's just pulling I think these are just character vectors. Okay. So it's not actually the numbers, but you can you could do it like as integer or something.
Okay. Numbers. But that HTML text like function is pulling like in the HTML, that phone number is still text.
Yeah.
I'm new to HTML stuff.
Oh, that's great. And I'm glossing over a lot of the technical things because you don't need so much of it.
Yeah.
But if you look at the, yeah, so here, like the class name, that's in text. By text, it just means whatever is within the tag that is then displayed to the web page.
Okay, so it's still text. Okay, cool.
So now we have our names, phones, and emails. Let's put this in a tibble all together. Object names not found. What? Oh, did I not? There we go. And now we look at the table and we have the names, phone numbers, and emails for everyone in the accounting department. And something I really want to, emphasize is that this is all the code, and it's really just the same couple lines copied and pasted. But that golden rule that we talked about earlier, was it really worth it to spend that much time to write something to capture 34 emails? And I would say probably not. But now it's given us the opportunity to spread this a little bit wider. Because see, we just looked at the accounting department. If you look at the actual Walton directory, we have all of these different departments, management, marketing, that all of them can be searched in the same way. If we look at them, let's just open a bunch. All of these pages are organized the same way, which means the HTML underneath them is all the same. So I'm just going to throw this in. I just pulled the name of each of those earlier and put them in a list using a paste function to create the URL for each one of these. You could also just put all the different URLs in a list. And then what we're going to do is take that little bit of code we wrote, wrap it in a function, and then run it against each one of these departments. And this is that next step of kind of expanding your code out further every time. So there's our code. Let's put it in a function called gather. Have it take a department. And there we go. And have it search read HTML. There we go. So we and we open and close the function. Now, I don't know if functions are something that you all are working with. You could also just run that code and change the URL every time and gather it all. It'd still be a lot quicker than searching for it. But with this, we can wrap into a function. Hopefully I've written that correctly in our first try. And we can run that function. So let's say tables. I'm going pretty quick now because we've moved off of web scraping and this is kind of just functional programming. But we can use lapply, something called list apply, and we can apply to the list of depths that we made earlier the function that we just put together from our code called gather, and run that. Ooh, and actually, let me show you one thing. Print depths. There we go. That should. Yeah, now when we run it, we can see as it prints the different departments out as it's searching for them. So then we can make a faculty list, find rows, tables, And here is the 224 professors in the Walton College of Business and their contact information saved for us here. Yeah, you know, I think that is pretty cool that we found one guy's information and we were able to spread it out to a bunch of people's information, and now we can spread it to a bunch of different departments. And one more thing I kind of just want to, let me see if I have, oh yeah, I wrote something here. I took that same code that we wrote and I looked in the Fulbright College. Fulbright College is organized the same way. So here are all the departments in the Fulbright College and all their URLs. So we can copy that, paste it. Let's call this the Fulbright, let's call it full faculty list. See if that runs properly. Looks like we have 13 tables in there. We did something different.
And there was a quick question in the chat, Austin. It says, can you paste that chunk in the chat?
Oh, sure. Which chunk?
It might be easier if you wanted to like send this code that you finish up.
Yeah, if you that the thing that Joel put in the chat very early on, which the Walton faculty info.html, that is basically I've written this up, knitted it together using what was it, Control-Shift-K, saved it under some random letters, and I used R Markdown to knit it together into HTML so that it can be shared, which makes it look, you know, something like this. But the one that we're sharing actually has descriptions of what we're doing and paragraphs explaining everything. So if you download that and open it in a web browser, it'll have all that information. But while we were talking, I just ran that, and we have here the 224 lists of Walton and 456 members of the Fulbright College that we've just gathered as well. And I haven't looked, but I'm imagining the other colleges on campus probably use the same format. So you could probably gather, now that you've written it, I mean, you can gather all of them. And the next step would be moving it, after you finish with this university, maybe expanding it to multiple different universities. And then, you know, maybe UAMS uses similar code. And that's kind of the end of this example. And one thing I really, and I have a few key points, but before I go, one thing I really wanted to emphasize from the beginning is that we start with something pretty small. You remember when we were looking for the guy's name, you know, we found how the name was organized. We wrote some code, and that's what did it. Well, that code was just copied for the other metadata, and then all that code was just copied into a function. So really, I mean, that's most of the work that we did right there. It's just that little bit right at the beginning. So in the gathering of web data, you know, there's a lot of finding the data beforehand, and that's kind of the big beginning. This collecting the data is what we just did, and then cleaning the data, you know, that's what you would do afterwards. A few things to remember before we finish up is to always be polite to your web administrators. Don't overload their servers with polls. You know, if something has 1,000 pages and you need text data from each one of those pages, maybe put a system sleep command every time you search it, instead of just hitting their servers 1,000 times and inadvertently shutting down their website. Web scraping is legal, but it may be against a couple terms of services. So if you have an account with someone and they see web scraping and they don't want you to, they might shut down that account. Some websites have what's called a robot.txt, a robot text file, which will inform you that they would not like to be scraped. Those are not legally binding, so that I'll leave that up to you. And finally, if you're scraping citizens of the EU, the GDPR, that's the General Data Protection Regulation, protects personal data from EU citizens from data gathering. Now, at the level of researcher, I don't think this has ever come up in court, but large companies have gotten in trouble for this. And, it's important to recognize. And with that, that's all I have for you today. Go forth and gather data. If you take some of the resources we give you and copy it and play with it a little bit yourself, you'll be going in no time. All right, so thank you all very much. Are there any more questions?
Awesome, that was great. Do you have any tips for people wanting to gather more numeric type data?
Such as
like I don't even really have an example because I've never tried to web scrape before, but kind of I don't know, with are most of the kind of uses tallying, I guess, tallying comments of things or something, but then you'd be generating the numeric data. But if the website had numerics on there that you could gather, are there differences for that?
What about financial data?
Yeah.
Yeah, and when we were looking up lobbying data, we were looking at the exact amount of each lobbying report. If you're seeing it displayed on a screen, it's saved in the HTML as the same way that text would be, so that it can be pulled out. Now, it might be pulled out as a character list, a character vector. So, you would just have to run as integer on that. Today we talked about static web pages, but when we are working with Arkansas COVID, some websites actually kind of embrace scraping, and they create APIs or tools that make it very easy. So when we scrape from their server, we send a URL request and it just sends back a table. It's in JSON, which is another XML format, but it sends back that XML format. We detangle it here and good to go.
Nice.
Some websites and a lot of government servers really embrace it, and some companies don't so well. Twitter makes it very difficult. Facebook makes it very difficult. Of course, the rule of thumb is that if you're seeing it on your computer, then there's a way you can get it.
Gotcha.
It's a question in the chat.
Oh, now I'm covering up the chat because I put
So could you run quantitative analysis with this, like regression or any predictive modeling?
So yeah, this is web scraping is about the data collection point. But we do actually a little bit. One project we worked on a long time ago involved pulling a large amount of text data in articles, and then we members of researchers on our campus ran sentiment analysis, and then tried to find ways of predicting the sentiment of different comments. I've just been asked to help out with a project that's going to try to predict if a comment either supports or doesn't support a certain policy, based on the actual text. And that's going to be using machine learning algorithms, regression, like the Arkansas COVID data. When we get it, that's just a database of numbers. So, you can run it numbers along with, ages, gender, and then you can run anything you want on that. Yeah, I gotta find a way to keep my chat open. There we go. Yeah. So if there are no other questions, I think I'll stop the recording, but I'm going to stick around here if y'all want to chat for a minute about it. All right.
Thanks.
Thank y'all very much.